All right, science guru, a.k.a. Jesse Miller, REACT program director and teaching lab specialist at the U of I, joining us this morning for our chemistry lesson. Welcome.
Thank you.
Again.
Yes. Well, you know,
segment 2 we are
That's
on.
right. And last week, I talked about the kinetics. I talked a little bit about kinetics and thermodynamics, and I said that leaves change color or start to change when the days are shorter than when the nights, or excuse me, the days are shorter than the nights.
Mm-hmm. Okay.
When the autumnal equinox happens, and then.
And that's obviously the direction we're moving in.
That's right. Now the days are getting shorter. When that happens, there's a buildup of chemicals in the plant that finally kind of take over, and the plant starts to shut down, or the leaves start to shut down, and they form this called separation layer between the leaf, the end of the stem of the leaf, and the branch. And when that happens, then the leaf eventually falls off. Now we're going to talk about why it changes color, and that's one of the big reasons why it changes color. When that happens, there's no longer any production of chlorophyll.
Okay.
Okay. And when the chlorophyll when the chlorophyll stops being produced, it just degrades. It degrades all the time, but it's not longer being brought up. And so the chlorophyll goes away, and what's left is what you see, okay, to some degree. So what I did here, just to illustrate this, I mashed up a bunch of leaves in my trusty mortar and pestle here, and then put some ethanol in it, and this I extracted. This is ethanol, and it's got plant juice, if you will, in it. It's got a lot of chlorophylls, and it's got the other thing. It's a plant juice, or could be Vulcan blood. Anyway, I just nerded out, didn't I? All right, so we're going to take this, and remember we talked about chromatography.
Yes.
And put it on a chromatography plate, and this is what we end up with. I just did this. And this one's a little messy. I didn't do a very good job of getting it even.
Oh,
but
so
as you look
see how
at
the
this,
colors separate.
that's right. You can see the colors separating. If we get a close-up on that, hopefully, you can see the.
There's orange and yellow and green.
The top is kind of the garbage color, that brownish stuff. Those are waste products.
Right.
And you'll notice oak leaves don't change colors; they just turn brown.
Right.
And that's all these waste products, and that's because they don't have this yellow portion, which are what's called xanthophylls and carotenoids.
Right.
Which, orange colors are carotenoids. That's what gives carrots their orange color. And you can see the green from the chlorophyll. So what happens is the chlorophyll goes away, and what you're left with is the yellows, which is why you see a lot of yellow on leaves.
Right.
Now that may beg the question, what about red? I don't see any red on here. Well, red's a little bit different. Red is produced when that separation layer forms. The plant continues to produce food, and it continues to produce sugar, and that sugar turns into what we call anthocyanins. Okay, and that has a red color. So the reason why you're not seeing any red here is because I picked green leaves, and there's none of that in there.
Got it.
Okay, so the red color isn't present normally in the plant. It is, but not in the same proportion that you would see it normally.
Is it more of a byproduct?
Yeah, it's the glucose is continuing being produced,
right,
but it has nowhere to go because of that separation layer, right? And so you see a lot of trees like maples turn red because it produces a lot of sugar. Sugar maples makes a lot of sugar. Oaks do not; they just turn brown and fall down. A lot of other plants, you just see the yellow because they don't produce a lot of sugar afterwards, and it's just left with the xanthophylls and the carotenoids. Okay. So that's why they change color. They don't really change color. They've always been that color.
It's just the
green goes. That's right. The absence of the green, you get to see the color that it is when the chlorophyll's not present.
And we did a story about this not too long ago, but the weather can affect how bright the colors are, right, when they change.
Right. Because it affects how much of those sugars are being produced, how much excess sugar there is available. We got kind of lucky this year that it's finally started to rain right before fall.
Well, because the U of I actually issued a report saying that we shouldn't expect, right before we got a bunch of our rain, saying that we shouldn't expect to see the bright fall colors that we're used to.
Yeah, the rain kind of saved us a little bit. It's probably not going to be as bright as what it normally was because of the drought. Drought obviously affects that. But also, what you want for really bright colors is a cold, rainy August.
Right.
Okay, or September. And we're kind of getting that. So you're seeing right now, I'm seeing a lot of reds coming out. So it's good. But not as bright as what it was last year. Last year was a fabulous.
Well, because it also depends on how long the leaves stay on the tree.
That's right. Because they started dying. They started dying during the drought, and you see a lot of trees that are already denuded almost because of the drought. So it'll still be colorful. I still see a lot of colors out there. So
good.
So why, I have a question. Sometimes you see fall, depending on where you go, you see the fall leaves changing, sometimes before the official start of fall, which is the autumnal equinox.
Right, and that's a lot of times that, well, there's other factors. I mean, that's the main factor that causes the leaves, but how dry the summer is. Like, we almost saw an early fall, so to speak, as far as leaves changing. They weren't going to change color necessarily; they were just going to die and fall off. But sometimes, if it's too hot and too sunny all summer long, the leaves kind of wear out, for lack of a better term, and you get that early separation, and then they change colors. Okay. So sometimes it can also drive an early fall. And as a matter of fact, I think this year the leaves are changing just a little bit quicker than I remember them changing last year. Because I do the same thing every year.
Right.
And the leaves, and I'm doing a little bit earlier this year than I normally do.
Than last year.
Yeah.
Interesting. All right, Jesse Miller, thanks very much. We appreciate it.
Thank you.
We'll be right back.